In the movie Interstellar, the character Cooper, portrayed by Matthew McConaughey, embarks on a daring journey into the vicinity of a supermassive black hole named Gargantua. Cooper ventures into the black hole Gargantua. Cooper starts encountering time dilation as hours near the event horizon translate to years on Earth. Witnessing gravitational lensing, he sees distorted images of objects behind the black hole. Crossing the event horizon, he enters a higher dimensional space where time, space, and memory intertwine. Communication with his daughter Murph transcends time, allowing him to transmit crucial data encoded in gravitational waves. While captivating, these events are fictional and deviate from the actual behavior of black holes. So here's what actually happens if you ever get lucky to fall into a black hole. Let's dive in. What is a black hole? Understanding why the prospect of plunging headlong or steering a spacecraft toward a black hole is far from rational requires diving into the fundamental essence of these colossal cosmic mysteries. Put simply, a black hole signifies a realm where the gravitational force reigns supreme, so overwhelmingly dominant that no light, or any form of matter, can elude its gravitational grip. The term black hole aptly captures their essence, as these entities typically remain obscured in darkness, neither emitting nor reflecting light. Their visibility only manifests when they seize upon stars or gas clouds venturing too close to their perimeter, delineated by the event horizon. Beyond this threshold resides the infinitesimal heart called the singularity, a minute point where gravity becomes a force of unparalleled might, contorting the fabric of space-time itself. This realm ventures beyond the confines of our present understanding of physics, rendering any conjectures about its nature relegated to the realm of speculation. While black holes might exude an air of exotic mystique to the general populace, they have seamlessly woven themselves into the scientific fabric. The notion of such entities had been the subject of contemplation among physicists for decades, a concept eventually solidified by Albert Einstein's theory of general relativity, which anticipated their existence. Yet it was the 1960s that witnessed the turning point, with the discovery of immensely compact stars propelling the concept into the scientific limelight. Black holes aren't all the same. There are variations that can be described using varying levels of complexity, including factors like spin and electrical charge. The outcome of your hypothetical plunge into a black hole might depend on the specific type you encounter. At its core, the black hole spectrum consists of three primary categories: stellar mass black holes, supermassive black holes, and intermediate mass black holes. Stellar mass black holes originate from the remnants of massive stars that have consumed their fuel and undergone gravitational collapse. In contrast, supermassive black holes dominate the cores of galaxies and attain their colossal sizes, often tens of billions of times the mass of our Sun, through processes like star consumption and mergers with other black holes. The intermediate mass black holes remain a puzzle, with only a handful of suspected instances identified thus far. Astronomers posit that these intermediate mass entities may come into existence through mechanisms akin to accretion, albeit on a more modest scale. A fascinating aspect emerges when considering the tidal forces near the event horizons of different-sized black holes. Despite their relatively smaller stature, stellar mass black holes exert more pronounced tidal effects compared to their larger counterparts. This peculiarity originates from an unexpected property of black holes. Smaller variants possess a heightened gravitational gradient, leading to a significant disparity in gravitational pull over short distances. This implies that even a brief journey into the proximity of a smaller black hole would be accompanied by a perceptible alteration in the gravitational environment. This intriguing phenomenon underscores the nuanced intricacies within the realm of black holes, as their gravitational behavior defies conventional expectations and adds a layer of complexity to their captivating nature. Now, what happens if you come across one? Imagine yourself adrift near a stellar mass black hole, a dormant behemoth lurking in the cosmic expanse. Your awareness of its presence would be limited to a mesmerizing yet ominous phenomenon: gravitational lensing, a distortion of light from distant stars as they dance through the gravitational field. This haunting preview sets the stage for an experience beyond imagination. As you venture closer to this enigmatic force, a metamorphosis of the most peculiar kind awaits: spaghettification. The powerful grip of gravity would seize hold of your body, elongating it in one direction while mercilessly compressing it in another, akin to taffy pulled to its limits. Picture this: Plunging feet first into the abyss would subject your toes to a gravitational force markedly stronger than that pulling on your head. The result is an agonizing contortion, an uncanny resemblance to a piece of spaghetti. In the face of such unrelenting forces, contemplation of cosmic revelations would likely yield to the sheer ordeal of the plunge. A grim fate would befall you well before reaching the ominous singularity, the heart of the black hole where space-time itself is unfathomably curved. Your form, once human, would be stretched and twisted beyond recognition, a haunting echo of your former self. What's astonishing is that this nightmarish sequence isn't confined to the realm of theoretical speculation. In 2014, astronomers bore witness to a cataclysmic event, a star's ill-fated approach to a black hole. The relentless tidal forces tore the star asunder, fragments spiraling past the event horizon while others were violently expelled into the cosmic void. This stark reality underscores the horrifying yet mesmerizing power of black holes, a force capable of unraveling even the most colossal celestial bodies into fragments of cosmic oblivion. Contrasting the experience of falling into a stellar mass black hole, a plunge into a supermassive or intermediate mass black hole might be less nightmarish. Although the inevitable outcome, death, remains unchanged, you might actually make it to the event horizon alive. In this scenario, you could potentially see the space around you as you cross the event horizon. However, no one beyond the black hole would be able to see you. Even if you shone a flashlight outward, the light would be drawn back into the singularity. Within the event horizon, you'd witness extreme gravitational forces distorting everything around you, an effect known as gravitational lensing, alongside the peculiar effects of time dilation. Irrespective of the type of black hole, the intense gravity would ultimately rip you apart. No material, including the human body, could withstand such forces intact. Thus, once you pass the event horizon, there's no escape. Breaking free would require moving faster than the speed of light, a feat impossible according to our current understanding. But here's the good news. There's no need for immediate concern. The nearest known black hole to Earth is a formidable 1,000 light-years away. However, there's reason to suspect that many lie closer, perhaps only a few dozen light-years distant. In fact, some scientists speculate that the hypothetical Planet 9 in our solar system could be a primordial black hole, approximately the size of a baseball. Considering this, if humanity develops advanced space travel technology and manages to reach a black hole, the possibility of direct observation and testing could arise. Still, due to the event horizon's nature as an inescapable threshold, certain secrets might forever remain beyond our reach. In the shadowy realm of black holes, fear takes hold. Their unseen force pulls at the edges of our reality, leaving no escape. It's a place where light vanishes, and the very fabric of who you are unravels. The terror of being stretched and torn, fading into the darkness, grips you. No rescue, no return. Just the relentless pull into the void where all is lost, into the all. So my friends, thank you for joining me today on this journey into a black hole. I hope you enjoyed this video, and please, if you haven't already, hit that subscribe button and like button. It helps me make more of these videos. So thank you again, and remember to always seek the truth.